Good morning all. Today we have topic multi-layer perceptron in machine learning subject. Now what is a perceptron? A perceptron is a single layer neural network that is used to classify linear data. It has four important components. First one, inputs, weights and biases, summation function and activation or transformation function. Now you can see over the slide that is diagram x1 x2 up to the xn. These are the input, w1 w2 wn. These are the weights of the respectively inputs. Next part we have the summation. The processing element s is equal to summation of the xi and wi. It means this is the summation function by which we need to do summation of the weight and inputs. Next we have the transfer function, which is known as the activation function, so denoted by the fs. And y is our output, and it could have many output, it could have the single output. So here we have the y1 y2 up to the yn. These are the n outputs over here. So this is a diagram of the neural network, or it is known as also artificial neural network diagram. Here we have the another diagram which shows x1 x2 up to xt are the inputs, and these inputs are taken by the function that is a plus f. And we have the psi wt x plus b. This is again another function which takes the input followed by the some weight, and that is denoted by the w and including by the biases. So weight is equal to weight plus learning rate into the expected minus predicted, and this is the power of the x, or multiply, we can say multiply of the x. So this is the just overall the formula of the neural network output. So or we can say this is the calculation of the weight. So this is the another approach by which we can just represent our perceptron function. So the plus f just represent the perceptron part. The perceptron is a simple binary classification algorithm proposed by the kernel scientist Frank Rosenblatt. It helps to divide a set of input signals into two parts, yes and no. But unlike many other classification algorithms, the perceptron was modeled after the essential unit of the human brain, the neuron, and has an uncanny ability to learn and solve complex problems. A perceptron is a very simple learning machine. It can take a few inputs, each of which was a way to signify how important it is, and generate an output decision of 0 or 1. However, when combined with many other perceptrons, it forms an artificial neural network. A neural network can theoretically answer any question given enough training data and computing power. So over the diagram you can see we have the perceptron input and output. So input is form of the x1 and w1 are the weight. So respectively we have x1 x2 x3 x4. These are the 5 up to the x5. These are the 5 inputs, and w1 to w5 these are the 5 weight respectively inputs. And output is just producing could be the y and could be the 0 or 1. So depend on the what value we are getting. It could be 0 or it could be 1, or we can say it is could be the yes or no. So output is just produced by the having by the some activation function, transformation function. So this is the example of the perceptron input and output. In the multi-layer perceptron, there can more than one linear layer combination of neurons. If we take the simple example, the 3-layer network, first layer will be the input layer and last layer will be the output layer, and the middle layer will be called hidden layer. We feed our input data into the input layer and take the output from the output layer. So we can increase the number of hidden layer as much as we want to make the model more complex according to the avatar. So this is generalized definition or concept of the multi-layer perceptron, and this is the topic of the our today's lecture, that is the multi-layer perceptron. So in the multi-layer perceptron, what we have the single input layer and single output layer, but we can have the multiple hidden layer. So in a single neural network we have the single input layer, single output layer, and single hidden layer. But when the multiple hidden layer are existed, so such kind of the model is just known as multi-layer perceptron model. So this is the idea about the multi-layer perceptron model. This is the example of the multi-layer perceptron where the input layer are existed only the one part, and first hidden layer, second output layer, and output layer we have. So here we have the multiple output layers. So this is a just generalized example of the multi-layer perceptron, but there is no requirement or there is no necessary that you should have at least one output layer or one input layer. Of course, input layer can be the one, but output layer or inner layer can have the multiple. So the when the multiple inner layers and multiple output layers are existed, then such kind of model is also known as the multi-layer perceptron. So perceptron means a function which just produce the output into the next layer. So if the same thing is happening by the multiple layer, and such kind of the task is known as the multi-layer perceptron functionalities. So now we should have a question: what is a multi-layer perceptron actually? A multi-layer perceptron, that is MLP, is a perceptron that teams up with the additional perceptrons stacked in the several layers to solve a complex problem. The diagram below or in the next slide shows and the MLP with the three layers. Each perceptron in the first layer on the left, that is the input layer, and send output to all the perceptron in the second layer, and that is the hidden layer, and the all perceptron in the second layer send outputs to the final layer on the right, that is the output layer.
Each perceptron sends multiple signals, one signal going to each perceptron in the next layer. For each signal, the perceptron uses different weights. In the diagram, every line going from the perceptron in one layer to the next layer represents a different output. Each layer can have a large number of perceptrons and there can be multiple layers, so the multi-layer perceptron can quickly become a very complex system. The multi-layer perceptron has another more common name, that is a neural network. A three-layer MLP like the diagram above is called non-deep or shallow neural network. An MLP with four or more layer is called a deep neural network. One difference between an MLP and a neural network is that in the classical perceptron, the decision function is a step function and the output is a binary. In neural network that involved from MLPs, other activation functions can be used, which result in outputs of real values, usually between 0 and 1 or between -1 and 1. This allows for probability based prediction or classification in terms of the items into the multiple levels. Now, structure of perceptron. The perceptron or neuron in the neural network has a simple but ingenious structure. It consists of the four parts as shown by our diagram. So first part, that is input values. The perceptron takes real values as its input. For example, if the perceptron is tasked with the classifying iris flower and open deep learning dataset, two inputs could be the length and width of the flower petals. Weight and biases. The weights represent the relatively importance of each of the weights to the classification decision. A bias weight is added and multiplied by a constant equal to the 1. And a weighted and sum. This is the third part. The input values are multiplied by the weights and summed up to create one aggregate values which is fed into the activation function. And last part, that is activation function. The activation function generates a classification decision. For example, the iris is classified as a setosa and versicolors. The perceptron learning process. A perceptron follows these steps. Number 1, takes the inputs, multiplies them by their weights and computes their sum. Why it is important? The weights allow the perceptron to evaluate the relative importance of each of the outputs. Neural network algorithms learn by discovering better and better weights that result in a more accurate prediction. There are several algorithms used to fine tune of the weights, and most common algorithm is called back propagation. Next one is adds Weiss factor and number 1 multiply via weights. Why it is important? This is a technical step that makes it possible to move the activation function curve up and down or left and right on the number graph. It makes it's possible to fine tune the numeric output of the perceptron. For more details, you can just go through the neural network Weisses. And next part we have, that is third point, that is feed the sum through the activation function. Why it is important? The activation function maps the input values to the required output values. For example, input values could be between 1 and 100 and output values can be 0 and 1. The activation function also helps the perceptron to learn when it is part of the multi-layer perceptron, that is MLP. Certain properties of the activation function, especially its non-linear structure or nature, make it possible to train complex neural network. For more detail, we can go for the activation function. And last part, that is the result, is the perceptron output. The perceptron output is a classification decision in a multi-layer perceptron. The output of the one layer's perceptron is the input of the next layer. The output of the final perceptron in the output layer is the final prediction of the perceptron learning model. Next part, we have from the classical perceptron to a full-fledged deep neural network. Although multi-layer perceptrons, that is MLP, and neural networks are essentially the same things, you need to add a new ingredients before an MLP becomes a full neural network. These are: number one, backpropagation. The backpropagation algorithm allows you to perform a backward pass, which helps tune the weight of the inputs. Backward propagation performs iterative backward passes, which attempts to minimize the loss or the difference between the known correct prediction and the actual model prediction. With these backward pass, the weights move towards an optimum that minimize the loss function and result in the most accurate prediction. Next, we have the hyperparameter. In a modern neural network, aspects of the multi-layer structure such as the number of layers, initial weights, and types of the activation functions, and the details of the learning process are treated as parameters and tuned to improve the performance of the neural network. Tuning per hyperparameter is an art and can have a huge impact on the performance of a neural network. Next part we have, that is advanced structure. Many neural networks use a complex structure that builds on the multi-layer perceptron. For example, NRN means a recurrent neural network, uses two neural networks in parallel. One runs on the training data from the beginning to end, and the other one from the end to the beginning, which helps the language processing. A convolutional neural network, that is CNN, uses three-dimensional MLP, essentially three multi-layer perceptron structure that learns the same data points. This is useful for color image, which have three layers of the depth, that is red, green, and blue. In a supervised classification system, each input vector is associated with a label or ground truth defining its class, or class label is given with the data. The output of the network gives a class score or prediction for each input. To measure the performance of the classifier, the loss function is defined. The loss will be high if the predicted class does not correspond to the true class. It will be the low otherwise. The activation functions are also non-linearity. Describe the input-output relations in a non-linear way. This gives the model power to be more flexible in describing arbitrary relationship. Here are some popular activation functions: sigmoid, ReLU, and 10H. Now we should have a caution how to train a model. So training the model is a more important part. So there are three basically steps in the training model. First one is a forward pass, next one is calculate the error or loss, and next one is a backward pass. Forward pass. In this step of the training of the model, we just pass the input to the model and multiply with weights and add voices at every layer and find the calculated output of the model, as you can see over the slide in the graph. Next step we have loss calculate. When we pass the data instance, we will get some output from the model that is called a predicted output, and we have the label with the data that is real output or expected output. Based upon these both, we calculate the loss that we have to backpropagate. Using the backpropagation algorithm, there is various loss function that we use based on our output and requirement. Last step we have, that is a backward pass. After calculating the loss, we backpropagate the loss and update the weights of the model by using the gradients. This is the main step in the training of the model. In this step, weights will adjust according to the gradient flow in that direction. Now these are the various references I have taken to make this video for your help as well. Today we have seen what is mean by the perceptron and what is the purpose of using the perceptron, and what is mean by the multi-layer perceptron and how we can define the multi-layer perceptron and what is the role of the multi-layer perceptron. So this is just idea about the multi-layer perceptron we have seen today. So in this video we have completed all the part of the multi-layer perceptron, and which is also known as a neural network as well, and it is completely part of the artificial neural network. So we have covered all those parts. So with this I need to thank you for all of you watching this video. Thank you once again. Thank you.